Okay, the next part is related to calculation of the impedance, admittance, inductance, capacitance of a specific configuration of the transmission line. Yeah. So you in this task, it's task 1, but subtask 2. We have a transmission line with this configuration. It's a 3-phase transmission line and with bundle with 2 conductors. So we have a specific configuration. You can see it's the steel reinforced aluminum conductor, and you have the parameter of this conductor here. And the task asks us for calculation of the following values: inductance, capacitance, series impedance, admittance. And you have the formula as well. And you know that how we calculate the inductance of transmission line. You have this formula that it's the neutral log, and the denominator is the equivalent of a distance, because it's 3-phase transmission line, and denominator is ds. ds is conductor radius, and the equivalent is equivalent distance between the conductor. And based of the type of configuration, and you can see the template here, you can calculate the equivalence of the distance. Actually, it is the geometric mean distance. Sorry. And according to this distance, 4 meter, 4 meters, and 7 meter, you can calculate the equivalent. And the denominator, ds, that is the GMR of the bundle conductor. And you can calculate based of this formula. If the configuration was without bundling, just GMR from this table was enough. However, since you have bundle transmission line, you have to use this formula. And the GMR can be extracted from the table according to the parameter of the conductor, and you have to find the root of GMR times DC. And the DC is the distance 100 centimeter, 10 centimeter. It's a distance between 2 conductors in bundling. And then you can calculate the inductance of the whole transmission line. Is the neutral log, denominator is this one, the equivalent GMD over GMR, GMR of the bundle system. That is this value. This one is in centimeter. You have to rewrite in the meter, and then you calculate the inductance. The next part will be calculation of the capacitance. You have the formula. You can see the formula is given by the task. It's the formula of the capacitance. However, this log is in the denominator, and the D equivalent is similar to previous task. However, denominator of the log will be different. DSC, it's the radius of the conductor for the capacitance calculation. Is the root of R, R is the radius of the conductor. According to this table, you have the diameter of the conductor. If you divide it by 2, you can calculate the R, the radius of the conductor. However, since it's bundle, you have to consider this 10 centimeter. And based of this formula, you can calculate DSC. And if you use this formula for the capacitance, you have the equivalent from the previous task and the DSC that you calculated before. In centimeter, you insert in meter. Then you can calculate the capacitance in nanofarad in kilometer. And then the task asks us for the Z, the impedance, and the admittance. And we know that how to calculate the impedance. It's the complex value. R is the resistance of the transmission line plus J omega is 2 pi times frequency and inductance times L is the length of the small L is the length of the transmission line. This R, and you can see this R is from here. The AC 60 hertz, the resistance of the transmission line, omega 2 pi frequency 60 hertz, and this one is the inductance, and 300 kilometer is the length of the transmission line. So based off this formula and calculation, you have the Z, the whole impedance of the transmission line. And the admittance of transmission line is J omega capacitance times the length of transmission line. And 2 pi 60 is transformer, and this one is the capacitance of transmission line that you calculated before, and 300 is the length, and you can see it's the final value for the admittance. And the last section of this task is a new transmission line. Is a transmission line, the length is 400 kilometer. The task gave us the resistance, inductance, and the capacitance. And we have to calculate the Z and Y. And we know that we had this formula. R, resistance, inductance, and the length of the transmission lines. The length is 400, different from the previous one. And you know that how to calculate the admittance. 2 pi frequency, capacitance, and the length of transmission line. Then we have to calculate the parameters, the coefficient of transmission line A, B, C, and D. And the task asks us how we can calculate these parameters. This one is the pi model, symmetrical pi model of the transmission line. And we know that Vs is the voltage of sending part, VR, voltage of the receiving side, current of receiving side, and the current of the sending side. According to this equivalent system, Vs, this one, will be VR plus voltage drop over this transmission, this impedance. The voltage drop here will be Z times the current passing through this impedance. And this current will be sum of this current and this current. Okay, so it's I. That is IR plus this current. And this current will be the voltage VR times the admittance Y, the half of Y. And based off this formula, you can calculate Vs is VR plus the voltage drop over Z. And according to this matrix, we know that the coefficient of the VR, the first row, the coefficient of the VR is A. And the coefficient of IR is B. And now we want to calculate C and D. According to this equivalent model, we know that IS, this current, is sum of this current and this one. And this current is Vs times half of Y. Vs, this one, plus this current. And this current itself consists of two parts, IR plus this current, VR Y divided by 2. So based of this formula, we can calculate the current from the sending side. And if we substitute Vs from this formula, we have this final result. And according to the second row of this matrix, we know that the coefficient of VR is C, and the coefficient of IR is D. So we can summarize that A and D are the same, and you can find from this formula 1 plus ZY divided by 2. B is Z, and C is this formula. So based of this formulation, we can calculate A, B, and C and D. Let me to erase to calculate the final subtask. Okay. The task asks us to calculate the wavelengths. We know that how to calculate the wavelengths. Previously, we calculate impedance and admittance. However, we know that the gamma is root of small z and a small y. That is impedance and admittance per length. It means that these values should be divided by the length of transmission line, and then you can calculate gamma based of this formula. And lambda, the wavelength, will be 2 pi divided by beta. And you know that gamma, the real part, is alpha plus j beta. The imaginary part of gamma will be used here. And this one is the wavelength of transmission line. And you know that the wavelength of the line is the length where the voltage angle difference between the sending end and the receiving end will be 360 degrees. It means that after approximately 5,000 kilometers, the angle of the receiving end will be same as angle of the sending end, the angle of voltage.